All right, this is page 380, number 10. And in this problem, we're supposed to, we've been given one root that's a solution to this equation, and we're supposed to solve it, so to find the other roots. So I know, according to the conjugate root theorem, that if I root 5 is a root, that negative I root 5 is also a root. And because this is a third degree equation, there should be one more. So because irrational roots show up in conjugate pairs and complex roots show up in imaginary pairs, I know that this root has to be just a rational number. So what I'm going to do is first divide by I root 5 synthetically, and then my second time through I'll have to divide by negative I root 5 because I won't get integer coefficients on the first round. So I'm going to spread this out horizontally because I know that I'm going to be dealing with complex roots. So 2x to the third minus 1x squared, 10x, and negative 5. And I already know this remainder should be 0, so I should get a 5 here. Anyway, bring down 2. 2 times negative I root 5 is negative 2I root 5. When I combine that with negative 1, I get negative 1 is the real part, minus 2I root 5. Okay, now this has to be multiplied by negative I root 5, so I'm going to take that down here. Negative 1 minus 2I root 5, and this is now going to be multiplied by negative I root 5. So when I multiply this by negative 1, it becomes a positive I root 5. And negative I root 5 times negative 2I root 5 gets me a positive 2I squared times root 5 squared, which is 5. So this is a negative 1. So 2 times 5 is 10 times negative 1. I'll have a negative 10 plus I root 5. So that goes here. And when I combine the 10 and the negative 10 cancel, and I just get an I root 5. So now, multiplying the I root 5 by negative I root 5, I get negative I squared times root 5 squared, so times 5. So this is a negative 1, so I get the opposite of negative 5, so I get a positive 5, which I know I had to get there, so got a 0 here. But, you know, this would be a constant x to the first x squared, but I can't do anything with these coefficients. You have to keep going and divide by the next root that you know in order to get integer coefficients here. So now I'll divide by, I divided by that root, I'll divide by just I root 5. And this will clean up really nicely now. So here's where my remainder will go, because I've taken out that column. So I know that has to be a 0, and I know this will have to be a negative I root 5. So bring down my 2. 2 times I root 5 is a positive 2I root 5. When I combine that with what's up above here, I just have a negative 1. Negative 1 times I root 5 is negative I root 5, which I knew it needed to be. So I have a 0. So that's good. Now, this will be a constant, and this will be an x to the first. So my depressed equation in this case is linear. So my depressed equation is 2 times x minus 1, and I set that equal to 0, and 2x is 1, so x is 1/2. So that's my third root. It's a rational number, positive 1/2. So anyway, that's it.